So, good day. I am Mark Keros. Today, we're gonna solve some electrical problems. So, first problem: a 25 horsepower motor has an efficiency of 84.9% when delivering 3 quarters of its rated output. So, calculate the total losses at this level. So, first, we identify the formula we're going to use this problem. So, we're going to use the efficiency formula. So, the the efficiency equals total output power all over total output power plus the power losses times 100. So first, then the second one, identify the given. We have the 25 HP horsepower and the 84.9 percentage. So this horsepower, we must convert it into watts. So we simply multiply this into 745.7 watts because 1 horsepower is equals to 745.7 watts. So we have the answer of 80,642.5 watts. And now we have the total power output. So we're going substitute all the given from this formula. So we have the efficiency of 84.9 equals the total output is 18,642.5 watts. Since the problem is we have the condition of the problem of 3 quarters, so we multiply this one into 3/4. Also this one, we multiply this in 3/4 plus the total losses. We multiply by 100 since we're talking of the percentage. So now we simply calculate this one in our calculator. So the power losses of the problem will be 2,486.76 watts. So our first problem are solved. So our second problem is how many armature conductors are in a generator given the following information. 2.73 times 10 raised to 6 Maxwell. P equals to 4, RPM equals 1,200, A equals 2, then E equals 240. So in this problem, we're going to use the generated EMF in a generator. So we have this formula. So since the given are already there, so we must identify P equals to 4, N equals to the RPM since in the Z is the unknown and the flux is equals to 0.73 times 10 Maxwell, so we convert it into Weber. So we have A equals to 2 and we have the generated EMF equals 240. So we simply substitute this one in our problem. So let's substitute this one. We have a generated EMF to 40 equals the 4 poles 1 times the RPM times the unknown times the flux, which is 2.73 times 10 raised to 6 times 10 raised to negative 8. So we have the 60 times the paths of the conductors we have, which is 2. We simply solve this in our calculator. So our conductors will be 219.28 conductors. So our second problem are solved.